Okay, welcome to lab 15, I should say 15, not 17. Concentration and reaction rate. Now, you're going to be carrying out a reaction today where you're going to be taking this purple stuff right here and carrying out a chemical reaction that will ultimately turn it orange. And you're going to be determining how long it takes for this reaction to occur at 3 different concentrations of one of the things you're going to react it with. This reaction is what's known as the chemical chameleon reaction. What you're going to do is you're going to turn manganese from purple to yellow-orange through a successive adding of electrons to the manganese ion. The manganese ion will start off with a +7 charge, and it will ultimately end up with a +4 charge as electrons get added to it. Every time manganese gains an electron, its color changes. It will transition from purple to blue to green, and then slowly settle in at a yellow-orange color. And you're going to take a look at how long this process takes to occur. So we're going to react this potassium permanganate with sucrose and sodium hydroxide. This is the final color that we're going to end up with. And we're going to place a beaker on this so that you can actually see at what point the color remains constant. Now, I could stop the stopwatch when it hits that color. However, what I'm going to want you to do is to pause the video when you think it's reached that color. You'll get the first trial for free so you can see exactly what the color should be. And then you're going to pause the video at the moment you think that the color change is complete, and then record how long to the nearest second it takes. Okay, let's get started. We are going to do this using 3 different concentrations of sucrose. First, we're going to use full-strength sucrose, and then we're going to cut the concentration in half twice. We're going to use half-strength sucrose, and then we're going to use quarter-strength sucrose. And then take a look at what happens to the time it takes the reaction to complete for each concentration. So for the first concentration, you'll take straight 20 milliliters of sucrose. For the second concentration, 10 milliliters of sucrose diluted to 20 milliliters using water. So we're cutting the concentration in half. Then for the third concentration, we'll use 5 milliliters of sucrose diluted to 20 with 15 milliliters of water. So each time you're going to be using 20 milliliters of sodium hydroxide, 5 milliliters of potassium permanganate, the purple stuff, and then the only thing we are going to change in this experiment is the concentration of sucrose. Now, there are many things that can affect reaction rate. A chemical reaction occurs when reacting particles collide together with enough force to break the old bonds. We call that activation energy. And where the molecules are at the correct orientation so that the atoms that are going to end up bonded to each other are the ones that collide with each other. The more collisions we have in a period of time, the faster the reaction will go. So the less time it takes, the faster the rate will be. Now, for example, I have this rather unfortunate addiction to jelly beans. Imagine I have 2 people who are going to eat jelly beans competitively. And one person can eat jelly beans, let's say 10 jelly beans a minute, and the other person can eat 20 jelly beans per minute. And you give them a pile of 100 jelly beans. Who's going to finish those jelly beans first? Well, the person who can eat 10 jelly beans per minute will take 10 minutes to finish all 100 jelly beans. But the person who can eat 20 jelly beans per minute will only take 5 minutes to get their pile of jelly beans finished. So as a result, the faster your rate, the less time it's going to take to complete the task. Now this is where you're going to collect your data. First, you're going to create a hypothesis, a prediction, that we will test with this experiment. If the concentration of sucrose is decreased, the rate of reaction will do what? Increase or decrease, and why? The data table will give you, for each concentration of sucrose, how many times in seconds did it take for it to happen the first time, and then we will repeat the experiment because you always repeat the experiment, just to eliminate error. And then you will average the time to the nearest whole number second and use that value for the x-axis on your graph. Here is your graph. It's already been set up for you. You will graph the volume of sucrose in milliliters, remember 20, 10, and 5, and how many seconds did it take for the reaction to complete, all the way from 0 to 250. Then there will be some conclusion questions to answer, but not many. All right, let's go ahead and start collecting data. So you'll put your time for the first trial here, and then we'll do it a second time, and then we'll dilute it, cut the concentration in half, and do the time twice, and then we'll cut the concentration in half again, and get the time there. All right, let's get this done. Okay, now we're going to do the first trial. And remember, I'm going to tell you when this is over. And you'll record the time, and then from then on, you're going to have to evaluate for yourself when the color change is complete. 20 milliliters of undiluted sucrose. And I will pour in the other two chemicals simultaneously. Sodium hydroxide, potassium permanganate. Here we go. Start. The green is fading. The green is fading. It's not gone entirely yet. Stop. Okay. At 47 seconds, it has reached its final color. This nice, rich, deep orangey yellow color. Second trial, undiluted sucrose. Adding the other two chemicals. Start. Stop. Okay, did you get where the color change ended? If not, go back and watch again until you get it. It's subtle, and you don't have to get it perfectly because you're going to average the two numbers together for your first trial of undiluted. Okay, time for the second concentration. 10 milliliters of sucrose diluted to 20 by adding water. And now we will add the other two chemicals simultaneously. Start. Stop. Okay, now I went way past where it turned color. So if you missed it, go back and watch it again. Let's do this a second trial. Second trial, 10 milliliters of sucrose diluted to 20 with distilled water. Adding in the other two chemicals. Start. That's it for the second concentration. Now it's time to do the third and final concentration, 2 trials. First trial at 5 milliliters of sucrose diluted to 20 with distilled water. Reset. Adding the other 2 chemicals. Start. Stop. Okay. Now one more trial at this lowest concentration. Reset. Five milliliters of sucrose diluted to 20 with distilled water. And adding in the 2 chemicals one last time. Start. 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 Okay, did you catch it? All right, to the best of your ability, it was very subtle. Now go ahead and average each trials together. You'll use the average to the nearest whole number second to graph your data. And you can go ahead, analyze it, and then answer the questions at the end, and you'll be all set. Thanks for joining me today.